Hello, welcome to Asevoxel. Here I will explain the controls dialog that you can use to rotate the model. This is Alfredo. You can rotate him with middle click and it pitches and yaws the model. Pitch and yaw are camera relative movements, so whenever you move up, it moves up, down, down, left and right. And if you combine pitch and yaw, you can roll, but I'll show that later. Here, go to the controls dialog, and these numbers that show here, model space x0, y1, c4, correspond to the Euler angle controls, which are the master rotation matrix that we use for rotating the model. So if you want to go back to a previous rotation that you have written down, you can do it with the Euler angles. For example, we can rotate it here. These are not very intuitive because, for example, if I change x, then y doesn't always behave the same way. See, there it is in a diagonal, and c behaves pretty much like roll, but it's not the best. This mode is better for canonical rotation. So if you had a rotation you had before and you want to go back to it, you input the numbers here. And another tool is that, as you see, model space here hasn't updated. That is in case that you want to write down this and you have moved this. This remains like it is unless you rotate with the mouse. Then it updates. Now, here we also have controls for orthogonal view, which I recommend you always leave on, and the scale controls. This slider does not have all the scale controls. For example, it has 50%, 100, 150, 200, 250, so on and so forth, from 50 to 500%. But if you use the mouse scroll wheel on the model, you will see that you can jump by 25 percentile each time. So it is more accurate to use the mouse wheel scrolling on the model. Now we have quick buttons here. Front view, as you can see, is all 0. Top 270, module of 90. Side 90 on Y, and isometric, which are these strange numbers. If you're familiar with rendering software or 3D software, you will see that these numbers are not what other programs call isometric, but trust me, for my strange way of calculating matrices, this is isometric. Then we have the absolute rotation. This, imagine a cube. For example, let's picture Alfredo here is a cube. We have the top face, the side face, and the front face. X will always rotate like this: front face, top face, back face, bottom face. So always like this. Y will always rotate front, side, back, side, front. So always like this. And C will always rotate top, side, bottom, side. So like this. This is the model space rotation. That's why it's called absolute rotation, model space, because it always rotates the model depending on the model, not on its current rotation. And now the best one, the one for, you know, modeling and previewing and everything, pitch, yaw, and roll for relative rotation. Relative rotation works as you expect. Pitch always moves the model up and down depending on the camera angle. So it is relative to the camera. It is always like this, never like this or like this or whatever you may have. yaw is always side to side, and roll is always clockwise or counterclockwise. Now, if you want to use the mouse with middle click and drag, you actually are using pitch and yaw sliders. Pitch and yaw and roll and absolute rotations don't update the value of the current rotation matrix to that coordinate system. So this won't change unless you actively move the sliders. So these sliders are only relative to themselves. For example, if I yaw to one side, yaw doesn't change. The one that does change are the Euler angles, because this is the master rotation. This is the actual values of the rotation matrix that we use to rotate the model. That's it.